Look at a modern globe, and India appears firmly locked into the Asian continent. But rewind the clock 200 million years, and you'll find it deep in the southern hemisphere. It was part of a massive supercontinent known as Gondwana. For 180 million years, Australia, Antarctica, Africa, South America, and India formed one continuous ecosystem. The name Gondwana itself tells a story of this ancient landscape. It's derived from Sanskrit, translating roughly to a vast region of forests and mountains, and specifically references the indigenous Gond tribe, who still live in the central forests of India today. Deep beneath this tranquil supercontinent, low-density magma from the Earth's mantle was rising. As it surged toward the surface, the immense pressure fractured the rock above, and the thick continental crust shattered. This violent subterranean rupture cast the Indian plate entirely adrift. It marked the beginning of a 9,000 kilometers solo migration across the ocean, a journey that would physically engineer its modern, life-sustaining geography. As the plates scattered, India and Madagascar drifted northward together. They shared a single landmass for tens of millions of years, crossing the ancient sea. Then, about 150 million years ago, a massive volcanic event at the Mascarene Plateau tore them apart. Deep Earth magma erupted to the surface, splitting Madagascar away and leaving massive, layered deposits of hardened lava along India's western edge. That towering wall of ancient hardened lava is what we now call the Western Ghats. The immense weight of this new mountain range acted like a geological fulcrum. It pressed the western edge down, forcing the entire tectonic plate to tilt downward toward the east. This slight but permanent slant dictates why almost all the major rivers in southern India flow west to east, ultimately draining into the Bay of Bengal. These peaks also became a massive meteorological barrier. When moist summer winds blow inland from the Arabian Sea, they crash directly into the Western Ghats. The air is forced upward, cools rapidly, and condenses into heavy rain clouds. By intercepting this ocean moisture, the violent creation of this volcanic wall provides the sole mechanism for the Indian monsoon system. It transforms the region into a lush agricultural powerhouse. Fast forward to roughly 80 million years ago, and another fracture separated India from Australia. Even today, the hills of India's eastern Ghats share the exact same age, rock structure, and magnetic properties as the mountains in Western Australia. This chart compares average tectonic plate velocities, and it reveals something staggering. Once separated from Australia, the Indian plate accelerated to a speed of 15 to 25 centimeters per year. By geological standards, that is a sprint. But that extreme velocity drove the continent directly over a deep Earth volcanic vent known as the Reunion Hotspot. As the plate passed over it 60 million years ago, enormous volumes of magma erupted onto the surface. The hardened result of that magma flow is the Deccan Traps. It is a colossal plateau of volcanic rock stretching across modern-day Maharashtra, Madhya Pradesh, and surrounding states. The biological cost was devastating. The toxic gases released by this hotspot, combined with the infamous Chicxulub asteroid impact in Mexico, triggered a mass extinction that wiped out native dinosaurs, including the massive Rajasaurus. This period of profound destruction removed the subcontinent's dominant predators. Without the threat of native dinosaurs, newly vacant ecological niches allowed early mammals to survive, diversify, and eventually dominate the land. After 9,000 kilometers, the migration reached its violent climax 50 million years ago. The Indian plate crashed head-on into the Eurasian plate. The immense kinetic energy of the impact had nowhere to go but up. The crust buckled and folded into the sky, creating a jagged 2,400-kilometer wall of rock known as the Himalayas. Because of their extreme altitude, these peaks act as an atmospheric trap. They capture thousands of tons of snow, compressing it into colossal, permanent glaciers. Every summer, rising temperatures slowly melt these massive ice structures, sending a constant flow of fresh water down into the valleys below. This precise glacial runoff carves through the landscape to birth massive river systems, the Ganga, Yamuna, Brahmaputra, and Indus. The human stakes are immense. These waterways provide the essential drinking water and agricultural irrigation required to sustain billions of people across the region. The civilizations that emerged here were built on a foundation laid by this 200 million year journey. From the volcanic forging of the Ghats to the high-speed collision that birthed the Himalayas, India's modern capacity to sustain billions of people is a direct outcome of its unique geological history of destruction and rebirth.